Question: the amount of paracetamol per tablet is believed to be normally distributed with mean 500 mg and standard deviation 160 mg. A dose of less than 300 mg is ineffective in dealing with toothache. In a trial of 20 people treated for toothache with a single tablet, what is the probability that two or more of them have less than the effective dose? So we solve this question. The mean is 500 milligram, and the standard deviation is 160 milligram. So the normal distribution is mean 500 and the variance 160 squared. It says a dose of less than 300 mg is ineffective. So the probability of ineffective is the probability that the random variable is smaller than 300. This equals 0.106. And it asks in a trial of 20 people treated for toothache with a single tablet, what is the probability that two of them have less than the effective dose? So the probability that two or more of them have less than the effective dose. So this has many cases. So this equals the probability that two have less than the effective dose plus the probability that three have less than the effective dose plus the probability that four have less than the effective dose, and plus continue until plus the probability that 20 all people have less than the effective dose. So if we do the work in this way, it's a huge work. We need to find the probability that two have less than the effective dose, and find the probability that three have less than the effective dose, and find the probability that four have less than the effective dose, and go on until the last one, 20 have less than the effective dose. So this is a huge work. But we can do this in another way. We know that the probability that nobody has less than the effective dose plus the probability that one has less than the effective dose plus two or more of them have less than the effective dose. So this equals 1. So we can find the probability that nobody has less than the effective dose, and find the probability that one has less than the effective dose, and use 1 to minus these two probabilities. Then we will get the probability that two or more of them have less than the effective dose. So first, we find the probability that nobody has less than the effective dose. This means that all 20 people have the effective dose. So this equals the probability that effective, because all 20 people have effective dose. So that is the probability of effective to the power of 20. The probability of effective equals 1 minus the probability of ineffective. This to the power of 20. And this equals 1 minus the probability of ineffective is 0.106 to the power of 20. This equals 0.106. Now, the probability that 1 is less than the effective dose. This equals so this probability also has a lot of cases. So there are 20 people. We list them here. People 1, people 2, people 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it can be the first person has less than the effective dose, and the left people have the effective dose. It also can be the fourth person has less than the effective dose, and the left people have the effective dose. It also can be anyone in the 20 people has less than the effective dose, and the left people have the effective dose. So there are many cases. So the total case is we choose one person from the 20 people. So there are so many ways, so many cases. And the probability of each case is one person has less than the effective dose. That is 0.106. Multiply the left 19 people have the effective dose. That is 1 minus 0.106. So the 19 people have the effective dose. So this should to the power of 19. So we multiply them. This is the number of cases. This is each case's probability. So this equals 0.252. Then the probability that two or more of them have less than the effective dose. This equals 1 minus the probability that nobody has less than the effective dose, minus the probability that one has less than the effective dose. This equals 1 minus 0.106 minus 0.254. This equals 0.642.